So the first class we're going to deal with is chapter 1, which is indices and logarithm. It's called numerical processing 1. In indices and logarithm, I will just go straight to the laws of indices. The first law states that when x raised to power a multiplies by x raised to power b is equal to x raised to power a plus b, or in the power, or let's say indices. The second one says when x raised to power a divided by x raised to power b, this is equal to x, or in the power a minus b. The third one says x raised to power 0 is 1. And this only apply for all values of x except if x is 0 itself. Take note of this, because 0 is always 0 no matter whatever. 0 is nothing, no matter whatever, is always 0. So and the fourth law states that when x raised to power negative index is equivalent to 1 over x raised to power that index that is in negative. So let's start solving. So with these examples, we are going to use them to explain these laws. Let's start with the first one. The first one says 10 square times 10 cube, or 10 raised to power 2 times 10 raised to power 3. So let's start. E. Now 10 raised to power 2 times 10 raised to power 3. What is the equivalent of this? This is something as saying 10 times 10 for this one, or times 10 times 10 times 10. By the time you do it this way, you say 10 times 10, 100, 100 times 10, 1000, 1000 times 10, 1000 times 10 is 10,000, 10,000 times 10 is 1 million. So you have something, 10,000 times 10 is 100,000, sorry for that. So you have something like this. The answer will equal to 0, 0, 0, 0, 0. This is your answer. On the other hand, if you express it as an indices, you have something like 10 times 10 times 10 times 10, which is like how many times is 10 multiplying itself, which is 1, 2, 3, 4, 5, which is 10 raised to power 5. This is your final answer. Now, what does this prove? This is trying to tell you that this 10 raised to power 5 is the same thing as the power of this 10 here plus the power of this 10 here, which is 10 raised to power 5. That proves our first law, that when an indices multiplies another one, is the same as adding the power. I can just do a little rough. Okay, let me know. Do you wanted to give another example? I think this proves it. You can use any other number and check, and you find that it's always true. That's for the first law. Let's go for the second one. B, which is 22n raised to power 7 divided by 2n raised to power 3. So let's divide this number. We have something like 22 times, let's open up this, n, that's 7 times n times n times n 4 times n 5 times n 6 times n 7. So all divided by, all you have at the other end, 2 times, let's open up this, n 1 times n 2 times n 3. So let's start cancelling out. When 2 cancel here, you have 1. When 2 cancel here, you have 11. So n cancels n cancels n cancels n. So you have something like 11 n times n times n, that's n raised to power 4. This is your answer. 11 n raised to power 4. Now, the whole number is not even our main problem here. The main thing is to prove our law of indices. So if you look at n here, you have n here is raised to power 7 and n here is raised to power 3. At the final answer after division, you have n raised to power what? 4. So we can say 7 minus 3 is giving you 4. This proves the second law, that when x raised to power e divided by x raised to power b, your final answer will be e. The first one is one that you are subtracting the second one from the first one, a minus b in power. That proves it. Then the next thing we are going to do is to prove the next one. Our next question is C, which is the same thing as 19 raised power 0. 19 raised power 0. And from our law of indices, we have been told that any number raised power 0, so long as that number is not 0, will give us 1. So we are trying to prove it here. So this 19 raised power 0, let's assume this 19. Assume that this is 19 raised to power anything at all. Let's say it's 19 raised to power 19 raised to power, let's say A. Are we together? That A is any indices that we don't know. A can be any value. Let's assume whole number value. So, and we know that any number divided by itself is what? 1. Any number at all divided by, so long as that number is not 0. So let's divide by itself is 1. So we can say 19 raised power A all over 19 raised power A is what? 1. That's established. Now, using the law of indices, this second law that we have here, when two numbers divide itself, the first one subtract from the second one. So when you apply that law here, you have something like 19, this is A minus A, which is the same thing as 19 raised to power 0, because A minus A is 0, so meaning that 19 raised to power 0 is actually this 19A over 19A. And we have already established that any number divided by itself is 1. So any number at all, if you like, use any value. You can say something like 2 raised to power 0. You can say is the same thing as 2 raised to power 1. Let's assume, let's use 1. 1 over 2 raised to power 1. We all know that 2 raised to power 1 is the same as 2 over 2, which is still 1. So putting it in indices form, you can say that this thing means 2 raised to power 1 minus 1, which then that 2 raised to power 0. So any number raised to power 0 will give you 1. So with this logic here, we will be able to prove that any number raised to power 0 is 1. So let's go to the next question. D. What we have in our D is 5 raised to power minus 2. 5 raised to power minus 2. The logic we can use here now is we can say that this thing is equal to 5 raised to power 0 minus 2. Hope we are together, because 0 minus anything is still that stuff. So this 0 minus 2 is something as 5 raised to power minus 2, because if you remove the 0, or 0 minus 2, let me say 0 minus 2 is still equal to minus 2. Are we together? And now if we apply this law here, where is the law? We are going to apply, now we need use logic to apply A minus B for the division rule. Now if we apply the second law, the third law, which states that any number raised to power 0 is 1. So these are the two laws we are going to apply. So now this is what I'm going to re-express in another form. This part here, I'll say this is the same thing as 5, because according to the division law, this will be dividing this, any number here minus the power here is the same thing as the one here divided by the one here. So this will be the same thing as 5 raised to power 0 divided by 5 raised to power 2. I don't know if this is making any sense, so because this thing, if imagine you are giving, let me give you an example. Imagine you are giving, let's say this is an example column. Imagine you are giving 2 raised to power 2 all over 2. Mind you, when you are doing with indices, this base must be the same before you can apply all this law. I think I forgot to say it in the beginning. You can't just come and say 2 raised to power 2 divided by 3 raised to power 3. You now come and start applying the law that this thing will also mean it will not work. The two base must be the same. So let me continue what I'm saying. So let's say you have 2 raised to power 2 over 2 raised power 5. This is equal to 2 raised power 2 minus 5. If you have to put it in the form of indices. So that's what I'm doing here. This 5 raised power 0 over 5 raised power 2, which is sitting as 5 raised power 0 minus 2. So any number raised power 0 from this our law here is 1. So the answer is 1 all over 5 square. So this proves to us that any number, this is just us proving these laws, but I don't think anybody wants you to prove it in the exam. Just know that 5 raised power minus 2 is the same as 1 over 5 square. Now the negative is out. If you bring it up again, the negative will come back. It will be in this form. So that proves our law here. So by so doing, we've already proved these 4 laws. We've already proven these 4 laws. So let's solve more examples. From here we have we've done 1, 2, 3, 4. So let's do this and that. The next one is E. 2 raised power 3 times 1 over 6 raised power minus 1. Now what we are going to do here now is just to solve indices. So from our law, 2 raised power 3 is same as 2 times 2 times 2, that's 8. So this is equal to 8. Oh, let me put it here. This is 8 times 2 times 2 times 2 times this 1 over 6 is what? Don't forget this is minus here. So minus means inverse. So it will be times 6. I don't know if you're making sense, because once from the law we did here, from this law we did here, let me do a little calculation. We said that when x raised power minus 1, it will be equal to 1 over x, right? At the same way, if you have something like 1 over x or raised power minus 1, that one will be equal to what? X, because this negative sign here, what it does is to inverse the number. Or I can prove it if in a more logical way. You can say, okay, 1 over x raised power minus 1 is the same as 1 all over 1 over x. Now it's already in this form that x raised power minus 1 is 1 over x. Instead of here and I is like trying to jump step, but for those that will not understand, that's what I'm trying to solve it further. So 1 over x raised power is the same as 1 all over 1 over x. By the time you solve this thing, remember what I told you about division in fraction. You just, when you say something like 1 divided by 1 over x, is the same thing as 1 times x over 1. So by the time you solve this, you are getting your x back, which is what we got here. So that's how we came about that. 1 over 6 raised power negative 1 will give us 6. So your final answer is 8 times 6, which is 48. So let's solve the last question. This is the last question. Question F. We have r multiplied by r raised power 0 multiplied by r raised power minus 1. One thing I want us to know is that whenever you see a number standing on its own, you shall know that it has a power, but that power is 1. You understand? Whenever you see a number standing on its own, know that it has a power of 1, because any number raised power 1 is still that number. Any number raised power 1 is still that number. Any number raised power 1 is still that. Maybe we can just say x raised power 1 is what? X. If you want to prove it logically, you can say x raised power 1 is same thing as x raised to power, let me say, x minus 0. But I think this is not necessary. But just know that any number raised power 1 is the same thing as x. So here now, we have to pick all these indices and solve it using our formula, the laws that we made earlier. So by the time you look at this, you remember that whenever indices are multiplying each other, what does it mean? It means that we can add the power. So this is now the same thing as r raised to power. Here is 1 plus 0 plus minus 5. This is the same thing as r raised to power what? Minus 4. And according to our law of indices, when you have minus, it will be 1 over that value. So this is equal to 1 all over r raised to power 4. This is your answer. So let's solve these examples from exercise 1A. Use it to conclude this class. This is number 19 and this is number 20. So the first one says 5x squared multiplied by 4x raised to power 0 multiplied by 2x raised to power minus 6. So applying our law of indices, just know that because what you just solve, these whole numbers will solve themselves without problem, while the indices solve themselves. But let me not do it that way. Let me just solve it as if we are solving it generally. We have for something like 5 times s squared means, no, you can solve it openly, like I can say 5 times s times x times 4 times. But let's just apply the law of indices instead of going through that long process. So this will be, let me take out the whole number, 5 times 4 times 2. These are the whole numbers. I've taken care of them. All times x. I'll start applying the law of indices. This is 2. This is plus 0. And this is plus minus 6. So 5 times 4 is what? 20. 20 times 2 is what? 40. This is 40 x raised to power. 2 plus 0 is 2. 2 minus plus minus 6 is minus 4. So this is your answer. You can also express it in this form, 40 over x raised to power 4. If you apply the inverse rule, so these are your answer, depending on the one you see. But most likely it will be in this form, because we want to apply all the rules. Number 20, you have 15 times 10 raised to power 4 divided by 3 times 10 raised to power minus 2. You know why we are adding this bracket? If you not add this bracket, and if you open up this bracket, board mass will take place, meaning that when you multiply this by this, you still divide it by this before you multiply it by this. So we are taking this bracket here so that you know that first you have to solve what is inside there before you divide it by whatever before this can divide by it. So let's go on. In this case, this thing will be something like 15 times 10 raised to power 4 all over 3 times 10 raised to power minus 2. Are we good to go? So let's apply the law of indices. If this cancel this, we have 5. Now the law of indices take place times let me put it in this one so we don't confuse ourselves further. 10 over minus 2. So if you use the law of indices, whatever that is in the numerator will be minus by whatever that is in the denominator. So this is the same thing as 5 times 10 raised to power 4 minus 2. Still the same thing I'm always saying about these signs. Always be careful when you are solving for them. So this is the same thing as 5 times 10 raised to power 6, because minus times minus is plus, so it will now be 2 plus 4 plus 2, which is what? 6. So this is your answer. And 5 times 10 raised to power 6 is the same thing as 5 million, because 10 raised to power 6 is 10 times 10 times 6 times, which is 1 million. 1 million times 5 is 5 million. So this is your answer. Thank you. If you have any questions, you can drop in the comment section. I'll see you in the next class.